we wait too long, we will be so lambat already. When we do normalization, if there is an attribute that does not depend on other key, which means do not involve in partial, where should we put? If you have an attribute in the original table, it should be like if you remember the example I used in the lecture, right? So you have a project number and you have employee number, and both of this composite key will determine how many hours that employee work for that particular project. That means this attribute is dependent on both the key. So other attributes may be dependent on part of the key, which is a partial transitive, a partial dependency, or other attributes may be dependent on a non-key attribute, meaning that it's a transitive dependency. If you have an attribute that does not depend on anything at all, doesn't depend on the non-attribute key, does not depend on the part of the primary key, it does not even depend on the composite key, that means it shouldn't be there, right? If the attribute is there, if it is not part of the, if it is not dependent on the part of the key, meaning that it is not partial dependency, if it is not dependent on a non-primary key, which means that it is a transitive dependency, it should be dependent on both the composite key. Okay, but if it is not dependent on both of the composite key, that means it shouldn't be there. The attribute should not belong to that table. All right, it should not belong to that table in the first place. Is that understandable, Wei Yang? Okay, all right. So let's look at the what do you call tutorial? Okay. So I want you to do this step by step, because if you don't, then you might be missing something. All right. If you can see my screen here, right? You have this long table. So you have to sort of draw out all of this attribute into one long table, maybe in your Excel, it doesn't matter, right? Because Excel can take a very long table, very long variables. So draw that table. You need to put in your data of your students, two students.
Summative assessment 1, which is next week, and the other one is quiz-based question, which is summative assessment 2. If I'm not mistaken, quiz-based exam is we have objective question. We also have fill in the blank. We also have true and false, and also we have matching question. Okay. So that's all for announcement. Okay, we have the announcement. First is a summative assessment 1, which is next week. Due date for final project, which is week 13, and summative assessment 2, which is quiz-based question. Okay, which is week 14. I hope you can refer all the information from MSK form. Okay. And then today is our tutorial 7. Tutorial 7 is more related related with normalization. Okay, I think we can proceed with tutorial 7. Okay. Okay. If you refer to your tutorial question, okay, we have one question only. You have to do normalize this table to third normal form. This table is actually is a first normal form. Okay, normalize the following table to third normal form and show each step. Okay, we have this table, and then the name of our table is Enrol Table, and under Enrol Table we have several attributes, which is class code, class description, student number, student name, address, city, state, until lecturer name. This is attribute under Enrol Table. Okay, for question number 1. Before you start, draw a table with all the above attributes. Populate the table with a few rows of data. One is data of 2 students, where each student taking WIA 2001 and WIA 2003. The second A2 is data of 1 student taking WIA 2001 and WIC 2002. And A3, you can use dummy data. So the question is how many rows of data that you have. So the question asks you, based on this information, based on this enroll table, you have to draw enroll table and enter all the attribute. You can use dummy data. Here is you must have 3 students, which is 2 students, each student taking WIA 201 and WIA 202, and the other the other student is taking WIA 201 and WIC 202. So the question is, how many rows of data that you have? Do you have? So student, how many rows? Student, based on question A, how many rows that you have? If we have 2 students that taking WIA 201 and WIA 203, and the other student taking WIA 201 and WIC 202. So how many rows that you have?
6.
Okay, betul 6. So you can use any dummy data. So actually, the question want to test you whether you know how to draw and enter all the data. So actually, if you enter data and based on this question, we have 6 rows. Okay. Okay, and after you have the table populated, determine the suitable primary key for the table. Hence, it should be a composite key. What is a composite key? A key that has more than one attribute. It is also known as compound key. And then after that, you have to draw functional dependency diagram, and then proceed to explain each step of normalization to the third normal form. Okay, so actually to draw the functional functional dependency diagram, you can refer to our lecture note. Okay, in our lecture note, we have set example how to draw the functional dependency diagram. And then if we refer this is actually the solution or the answer for this question. First, A, you already answer, which is you have based on the data you put based on the student 1, student 2, and student 3, we have 6 rows, and then after that, based on that one, you have to identify the primary key, where the primary key you must know each should be a composite key. That one is a hint from the question, where the key that has more than one attribute, which is a composite key. So if you look here, for our enroll table, actually this enroll table is a first normal form. Okay, first normal form. And then problem with first normal form, there is a redundancy with respect to entering all the data into a computer for each every class in which the student enroll. For example, because like a question, if you refer question A, where one student taking two courses, you must enter 2 times for each student. Okay. For example, the student name, address, and exam will have to be entered for each class that he takes. If he takes 4 classes, his name will have to be entered 4 times. Okay, 4 classes or 4 courses. Okay, his name will be entered 4 times. That this one is a problem with first normal form, and then if the location of the class, the other one is if the location of the class changes brooding or record in the enroll file for the class will have to be updated. The brooding name and the address are transitively dependent upon the brooding number. So after you identify primary key, which is your primary key is a class code and student number, which is based on this attribute. You must identify the primary key. Okay, and then based on this, we can use a primary key. Our primary key for this table is a class code and a student number. And then based on the this table, you have to draw the dependency diagram, functional dependency diagram. And then this is a type of functional dependency. We have a partially dependency, and we have also transitive dependency. Partially dependency and transitive dependency occur in first normal form. Okay. What is a functional dependency? Functional dependency is which the determinant is only part of the primary key. And then transitive dependency is an attribute functionally depend on other non-key. And then also when you draw the functional dependency diagram, you have to show all the partial dependency and transitive dependency in your diagram. This is example. This example is based on our lecture note. This is example of first normal form. Dependency diagram for first normal form. So you have to draw this kind of diagram, but based on our question. Okay, you have to draw the enroll table. And you have the diagram for enroll table, and then you have to show all the dependency, partial dependency and transitive dependency in your diagram. For this example, first normal form, we have project number and employee number as our primary key, but in our question, our primary key is a class code and student number. Okay, and then you have to show the partial dependency, which is in this example, partial dependency project number determine project name. If you look here, project number determine project name, and then employee number determine employee name, job class, charge hour, and hours. And then also job class. This is a partial dependency, and this is we also have a transitive dependency, which is transitive dependencies is a sorry. Job class determine charge hour. This is based on this example. But in our example, you have to identify based on this class code. Class code determine what? Class code determine class description, student number, student name, address, and so on. And student number determine student name, address, course code, and so on. Okay, this is partial dependencies, and also you have to show the transitive dependencies, where based on this transitive dependencies is like lecture number determine lecture name, also building number determine building name, building address, and so on. Okay, so the important here is after you draw the dependency diagram, function dependency diagram for first normal form, you must show all the partial dependency and transitive dependency in your diagram. Okay, and then move to second normal form. Conversion to second normal form. How to convert? Make new table to eliminate partial dependencies. So because in first normal form we have partial dependencies. All partial dependency we need to eliminate. Okay, and then second normal form, the purpose of second normal form is to eliminate all the partial dependencies. And then how to and then you must to eliminate that, we must write each key component on the spec line. Write each key component on spec line, then write original composite key on the last line. Each component will become key in your table, and determine those attributes that are dependent on the other attribute. This is how you can convert from first normal form to second normal form. But the purpose of second normal form is to eliminate partial dependencies. Okay, because in first normal form we have partial dependencies and we have transitive dependencies, and then second normal form we have to eliminate all the partial dependencies from first normal form to be second normal form. And then this is example, we have, after you eliminate all the partial dependencies, we have three tables, which is student table, class table, and enroll table. And then for each table, you have to identify their primary key and all the attributes. For example, student, we have a primary key, student number, and all the attribute under student table is student name, address, city, state, zip, major, code, and major description. And also we have class table, we have class code is a primary key for class table. We have class description, class start date, class start time, classroom number, building number, and so on. And lastly, we have enroll table. And we in enroll table, we have a primary key, which is composite primary key, which is student number and class code. And then student number and class code determine course grade. And then a problem in for second normal form is if the location, for example here in our example, if location of the class changing building or record in class file for the class will have to be updated. The building name and address are actually here is transitively dependent upon the building number. And then another one is lecture name are also transitively depend on the lecture note. The problem here in second normal form, we still have transitively dependent. Okay, so to convert second normal form to third normal form is you have to remove all the transitively dependent. Okay. Please remember we have partial dependency and transitive dependency. First normal form, we have partial dependency and transitive dependency in our table. And third normal form, all the partial dependency we already remove, and then but still have transitive dependency in second normal form. And then to convert second normal form to a third normal form, all the transitive dependency we must remove from the table. Okay. So this is example of functional dependency diagram for second number form. So based on here, we have three table like this example. We have three table, which is we have table student, class, and table enroll. And for each table, you must show whether there is a transitive dependency or not. Okay, like here we still have transitive dependencies for employee number. Sorry, job class determine charge hour. And then for our example, we still have transitive dependencies. Sorry. In a class table. Okay, transitive dependencies in class table. For example, building number. Building number determine building name, building address, building name and building address. So building number determine building name and building address. This dependency we call transitive dependencies. And then also in a lecture, okay, lecture code determine lecture name. Also we have what we call a transitive dependencies. And student also here major code determine major description. Okay, so this is all transitive dependencies where we must remove all the transitive dependencies to convert second number form to be third number form. Okay. And please remember, in second number form we already remove all the partial dependency, meaning partial dependency already in second number form we don't have any partial dependency anymore. Okay, in second number form. And then the purpose of convert first number form to second number form is to eliminate partial dependencies. Okay. And then third number form conversion to third number form step make new table to eliminate transitive dependencies. Okay, so in third number form from second number form to third number form, we have to eliminate all transitive dependency that we have in our table, and then identify each new determine. For every transitive dependency, write it determined as a PK for new table. So after you eliminate, you identify each attribute, which attribute is can be a determinant or can be a primary key. Okay, for this example. Lecture code can be a primary key that where lecture code can determine lecture name. Also, building number also can be has a primary key that determine building name, building address, and major code also can be primary key for to determine major description. Okay. And then determinant is any attribute whose value determine other value within a row. Okay, this is determinant. Okay, and then what is a table? What is a third number form? Third number form actually is when is in second number form and contain no transitive dependencies. Okay, third number form no transitive dependencies. Second number form no partial dependencies. Okay, and then this is after you convert after you convert second number form to third number form by follow this step, you have seven table, which is we have major table, student table, boarding table, lecture table, department table, class table, enroll table. Okay, but here department, some if you maybe some of you don't have a department table in your answer. Okay, I'm sure some of you don't have department table in your answer because department table is quite, because attribute for the department is we don't have any attribute. Not we have a attribute for department, but the department code we don't have any department code for our attribute, if I'm not mistaken. So here we have no department code. Okay. Okay, so for each table, we must have a primary key and attribute, and you must make sure for each table there is no transitive dependencies for each table. Okay. Okay, this is explanation why we have why we must have department table. Okay, why we must have department table here, because in our first normal form we don't have any any attribute for department for department. Okay, here okay, and then this is the explanation why we must have a department table. Okay, a relation is in third normal form if and only if it is in second normal form, as I said earlier, and no non-key field are transitive dependent upon the key field. Okay, so third normal form we have no transitive dependency anymore. Okay, there is no non-key field can be functionally dependent upon other no key field. Okay, not also that if you have lecture, for example, lecture, we have lecture code, lecture name, and department name. Do we have department name here? Oh, this is just an explanation why we have a department table. For example, we have department name. Okay, lecture table. We have a lecture code for primary key. Has a primary key for this table, and then we have attribute, lecture name, and department name. And then the lecture object, lecture table is not in third normal form, since the department name is transitively dependent upon the department code. We solve this problem with create a new table to eliminate transitively dependent. Okay, to eliminate all the transitively dependency. So we have two table here. First is lecture, which is lecture code, lecture name, and department code. And then the other table is a department table, which is we have department code as a primary key, and then we have department name. Because in our first initial first table for lecture is we have department name. So if our table, if lecture table have department name, this table is not in third normal form. Okay, is not because the department name is transitively depend upon department code. So that's why we have to create another table to eliminate transitive dependency. Okay, transitive dependencies. So we create department table that contain department code as a primary key, and we have a department name. Okay, that's why we have a department table in our answer. And then note that here is an assumption. Other is an assumption that we can make is a different building may have a same number, a room number. Example, room 101 in building A and room 101 in building B. Therefore, we have building number, a building table where building number is our primary key for building table, and attribute building name and building address. And then we have also class table. We have a class code, class description, and then we have also building number here. Okay, as a attribute in class table. Okay, and then building number, we link class table with the building table. And then you may have you may even have a room table, but this one is not applicable in this question, where room table we have room number, building number, and capacity and flow. This is extra, not in our in this question. Okay, also we can also have a room table where room table have room number, building number, and capacity and flow, where building number we link room table with the building, and then we have here a capacity and flow, because if floor have a different room, okay, number, have a room number, okay, with maybe different building may have a same building room number. Okay, and then this is first assumption where different building may have a same room number, but we also another assumption where each room has a unique number, so no two building will have the same room number. So for example, room A11 A101 in building A, room B101 in building B. So different building have different each building have different number, where room number is a unique number. So we have here a building table contain building number, building name, and building address, where building number is our primary key for building, and we have also a class table, and here we also have a room table where building number is our attribute under room table, where building number we link room table with the building and class. Okay, I think that's all. But please remember, class, for this question, first you have to draw functional dependency diagram for each normalization, for first normal form, for second normal form, and for third normal form. You have to draw functional dependency diagram, and for functional dependency diagram that you drawn, or you must show all the dependency that we have whether we have a transitive dependency or partial dependencies. Okay. Like this, all the dependency you must show in your functional dependency diagram. In your diagram, you must show if there is a transitive dependency, partial dependency, you must show. Okay. If there is no dependency, no need to show. Okay. But you have to show the primary key and attribute for each table, and then I think that's all a class for our tutorial, and I think you already submit your answer. Okay. I will look if I have time. I will look your your answer. Okay. I think that's all. I think. Okay, class. Any question, class? You can also ask me about your project if you have a question about your project. Yeah, you must show functional dependency diagram. Must show no, you must draw function function dependency diagram for first, second, and third normal form. Your functional function dependency diagram for first normal form, you must show the transitive dependency and partial dependency. For second normal form, you must show the transitive dependency, and third normal form, we don't have any dependencies anymore, so no need to show. Just show the dependencies between primary key and attribute. Okay. Yes, you must show transitive dependency for second normal form. And also the dependencies between primary key and all the attribute. First, you have to know what is the transitive dependency and functional dependency. Transitive dependency is the dependency between attribute A and attribute B. Attribute A determine attribute B. This is transitive dependencies. Okay. Yes, betul. Correct. For first normal form, you must also show transitive, because in first normal form we have partial dependencies and transitive dependencies. After we convert first normal form to be a second normal form, all partial dependencies already removed. So in second normal form, we don't have partial dependency anymore. So in second normal form, you just to show all the transitive dependencies. Okay, and then in third normal form, we don't have any partial or transitive dependency. Okay. Okay, class. Any question about project? Any question about project? No, class? I think our project for database is not too difficult. Okay, your project for statistic is quite tough lah. For statistics, I agree. The project for statistics is quite tough, but the project for your database is not too difficult. Okay. You just the important one, you just get all the business rule from company, and based on the business rule, business activity, you draw the ERD, okay, and database for that. That's all, okay. And then you develop the database system for that company and show several query for database system, and you screenshot and print, you screenshot and put in your report, and that's all. And then you present your project and give submit your video presentation to, that's all, okay, for your database project. Okay, class, if you have no question, I think we can stop now. But please remember, class, your for your final exam, we have two type summative. We have two type summative, which is summative 1 is next week, and summative 2 is on week 14. Summative 2 is quiz-based question, and summative 1 is a assignment-based question. Okay.
Sorry, doctor. I want to ask questions regarding the assignment.
Assignment? What assignment?
For database, yeah.
Final exam assignment or what? Final exam assignment, you cannot ask me.
No, I mean a group project, yeah.
Okay, group project. Okay.
Because after we attend the business rules, then we do the relationship and ERD, right?
Okay.
But there is one instructions in the group project which is list out some of the requirements from the user. Can I know what is it?
User user is who want to use. User is the person that use your system. This is a user.
Okay, so
you can in your case, the user is actually maybe a company, the admin of the company.
Yeah.
So you can ask the company what the requirement, or you can assume based on the based on your business. You can assume the requirement. Also can.
Okay.
But easy if you just get from the, maybe you can ask the company what is the requirement that the company wants, something like that lah.
The requirement is like the requirement for the database design, is it?
Yes.
Oh, okay, I see. Okay, thank you, doctor.
Okay. Yes, Rania, business room you can obtain from business operation, business activity, and so on. That's why first you have to get all the information related with business operation and business activity from the company. Based on that business operation and business activity, you can extract, you can determine the business rule. And after you get the business rules, actually you can show back to the company whether your business rules is correct or not. Okay, after that, if the company agree this is the rule, and then you can proceed. If you want to show, I think better if you want, you can show, or you can assume your business rule based on business operation and business activity. But business operation and business activity, you must get the real one from the company, something like that. For the database platform that we use, we can use any database system as long. Yes, we can use. I think easy if you use MySQL. MySQL also can. Yes, you can use any database as long as a database. May I know what is different between actually ERD is an ERD implementable ERD is the same. Yes, correct. One as Waliana. Yes, correct. You can this example, yes, you can use. Yes, no need to link your database to particular system. You just I'm sure you cannot use a real database from the company. You just create your just database system, default database system, and you create your database, and then you put some query, and then your system can give the output is okay. Do we need to add the entity we created after normalization into implementable area? If suitable, you can add the entities, but depend on after you do the normalization is depend. You can add also the entities, extra entity after normalization. Okay. User requirement is the activity that the employee must be able to know. User requirement is not task. User requirement is a requirement based on the system. Like because you want to do the you want to propose, or you want to propose, or maybe we can say you want to propose, let's say you want to propose a database system for the user. What is the requirement that the user wants for the system? That's all, not the task that the user need to perform. No, the requirement, what type of requirement that the user want. If you want to propose, because let's say you want to propose a database system for the user, what type of requirement? Like, for example, let's say the interface. The interface of the system must use this one, something like that. Okay. Mana boleh? We cannot. All the table must link with each other. All the table must have a relationship with the other, unless the table is not related with the others. I'm not sure whether your table have a fully dependent. I'm not sure, but normally all the tables must link, must have relationship with each other, with another table. That's why we have we must have for every table, we must have for primary key, and then we must have the attribute, then that can link table A to the table B to the table C, and so on. Okay. If you ask me about our tutorial, for your tutorial, you no need to do to draw ER diagram for each normalization. You just need to draw the dependency diagram, functionally dependency diagram. Your assignment, you can, because for each normalization we have you can draw the ER diagram. Yes, for your assignment, yes. But for what do you mean some are spread in other table? Actually, yes, because you already put a column. Actually, because each column represent the attribute. After you do normalization, some column you already move to the other table. Okay. Some column you move to other table. So maybe that's why after you do the normalization process, some column are spread from other table. Yes, some column. Yes, you, because column is every column is actually the attribute for the table. Okay.
Doktor. Hello, Doktor.
Hello, ya. Yeah.
Yang tadi tu kan, yang Doktor cakap tadi tu kan. Kan
Yang mana?
Yang normalization tadi.
Okay.
Contoh saya dah buat normalization.
Okay.
So dah ada dua different entities kan.
Different entity, yeah. Different entities mean different table, is it?
Yes.
Okay.
So ada dua different entities. Lepas tu some of the attribute from the entities is a foreign key.
Okay.
So for the table yang lagi satu tu, so dia kena
foreign key ni dia link tau. Dia akan link satu table dengan table yang lain. So memang kena ada lah.
Kena ada. Lepas tu dalam table tu kena ada lah foreign key tu, data foreign key tu.
Betul lah. Sebab foreign key ni, apa foreign key? Foreign key akan link one table to the other table. Is it correct?
Yes.
So let's say table A, foreign key dia 1. So in table B, attribute 1 tu mesti ada dekat table B.
Okay, okay.
Sebab
Okay,
dia
faham.
foreign key. Okay.
Okay, thank you, Doktor.
Yeah, okay. Okay, class, I think if you have no question, I think we can stop now. I think if you have any question related with our project, you can email or WhatsApp me, or you can send a message through our team. Okay, class? Okay, class, thank you. And okay, bye.
Thank you, Doctor.
Okay.
Thank you, Doktor.